Today we're going to finish up with our Algebra 1 curriculum. And our last thing that we're going to talk about is section 14.3, and it's probability of compound events. Obviously, when you turn in your homework for this particular topic, you are then done with Algebra 1. So then hopefully you will have a good break from math until next year. Probability of compound events. A single event taking place is really what we've talked about so far. Like you stick your hand into a bucket and you pull out 2 coins. Okay, that's in a single event. You do it one time. The probability of a single event might be, what's the probability of rain today? But when I start putting single events together, the probability of rain today and tomorrow. That's what we consider a compound event. If the compound events don't affect each other, just because it rains today doesn't mean it's going to rain tomorrow, and just because it rains tomorrow doesn't mean it's going to rain today. Those are called independent. So the probability of A and B is the same as the probability of A times the probability of B. These are called compound independent events. Okay? So let's say that there's a 40% chance of rain today and an 80% chance of rain tomorrow. Let me make sure that's recording. It is. Okay, so I'm going to take that and move it into a decimal so I can do math on it. So that's decimal 4, 80%, decimal 80. When I multiply those together, I get decimal 32. So there's a 32% chance of rain today and tomorrow. Because remember, I have to move my decimal 2 places to the right, which gives me 32%. All right, let's do another one. All right. Okay. Roberta is flying from Birmingham to Chicago to visit her grandmother. She has to fly from Birmingham to Houston on the first leg of her trip. In Houston, she changes planes and heads on to Chicago. The airline reports that the flight from Birmingham to Houston has a 90% on-time record, and the flight from Houston to Chicago has a 50% on-time record. What is the probability that both flights will be on time? So we have a 90% for my A event and a 50% for my B event. Now, just because one is on time doesn't make the other one on time. So they're independent. They do not depend on each other, but they're compound because 2 things must occur. So that's going to be decimal 90 because remember I moved the decimal 2 places to the left. This is going to be decimal 50. So I'm going to get a decimal 45 or a 45% chance of them both being on time. Sometimes, however, my events are compound, but they're dependent. One depends on the other. And I'm going to use a deck of cards to try and show you this. But the probability of A and B, if they are compound and dependent, is going to end up being, it's the same thing. It's the probability of A times the probability of B, but one affects the other. So let's say we have all the diamonds from a deck of cards. So there's 13 of them. And I want to know what the probability is that you're going to draw a king and a 10 if you draw twice from the card. If they are dependent, that means I'm not going to put the card back in the deck. So I show you the deck of cards. I ask you to pull the card out. the probability that you're going to get a king, there's one king in these 13 cards. So it's one success out of 13 total. But let's say you pull out, I don't know, you pull out this card, okay? That was trying to get a king. Now I'm trying to get a 10, and there's only one 10, so the success is 1. But now how many cards do I have? See, I pulled that one card out, so now I only have 12 cards. So this event, the second draw, was dependent on the first event. That's why it's a compound dependent. So when I multiply these two things together, I get 1 over 151, which is equal to 0.006, and again, you can use your calculator on this, which is 0.6%. That's not very high. You wouldn't want to make a bet on that, okay? All right, let's do another one of these, compound dependent. All right, this one's in your book, okay? It says a bag of marbles. This is number 2 in your book on page 770 if you want to get your book out. Okay, a bag of marbles contains 8 red, 12 blue, 9 yellow, and 11 green. All right, and I want to know what's the probability. Okay, you're going to draw out 3 times. What's the probability of getting a red, getting a blue, and then getting a green? Okay, so 3 different events. The probability of, well, first we'd have to figure out how many we have. So that's going to be 20 and 20 more. I've got 40 total. Okay, so there's 40 total marbles, so that's what goes on the bottom. Okay, the probability of getting a red, any of these 8 red would be considered successful. So that would be 8 out of 40. I draw a marble out. Now I want to know what the probability of getting a blue is. Well, there's 12 possible blues, but now I've already pulled one marble out, so now there's 39 marbles. Okay, so then I go on and I go, okay, green. There's 11 green. But now I only have 38 marbles, okay? So I can reduce these to lowest terms to make it easier. If I divide this one by 8, I'm going to get 1 over 5. This one by 3 is going to give me 4 over 13. And that one can't be reduced at all. Okay, so when I multiply that out, I'm going to get 44 over 2,470, which I can divide that out. Actually, I can reduce it, but I can divide it out on my calculator and find out what the percent is. So 44 divided by 2,470 is going to give me a 0.0178. I'm going to move my decimal 2 places to the right, and it's going to give me, rounded off, 2%. Okay, let's go on. Still the same problem here. This time I want the probability of a blue, a yellow, and a yellow. Okay, so probability of blue, 12 over 40. Probability of yellow is a 9 over 39. But the probability of another yellow, now I've already pulled one yellow, so that changes to 8. I no longer have 9 yellows, I have 8 yellows, and this goes down to 38. Now these again are what we would call compound dependent problems. So when I work our way through on this one, I'm going to get to the point as I multiply out that I'm going to get reduced down 18 over 1,235. Okay, I'm going to divide that. The top divided by the bottom, 18 divided by 1,235 is going to give me decimal 0.145. I'm going to move my decimal, it rounds to 1%. Okay? One more on this particular problem. What is the probability that I'm going to get red, yellow, and not green? Okay? Red, yellow, and not green. Okay, probability of the red is 8/40. Probability of the yellow is 9/39. But then we need to think about the probability of not green. Okay, if I have done the total of 40, but then I have 17 here, let's see, not green, I've already used 2 that would not be green. Okay, so the green is 11, so I've got 40 minus 11, which is 29, okay? That's 29 possibilities that aren't green, but I've already used 2 of them. So I get 29 minus these 2 is going to give me 27/38, okay? Multiply that all out and you would end up getting 81/2,470, which is going to give me decimal 0.32 or 3%. Okay, so you can see how that's done out. Another one of these problems, and we'll just do one of this. Let's say I have 4 sunglasses, 6 hairbrushes, and 5 keychains. Okay, and I'm going to select from this group. Now that's going to give me a total of 15 right there. And I want to know the probability that I get one sunglass, 1 hairbrush, and 1 keychain. Okay, probability of the sunglasses is 4/15 times hairbrush, 6/14 times keychain, 5/13. You would multiply that out, divide the top by the bottom, and get your answer. It's going to reduce down to 4/91. All right, another type of problem is called a mutually exclusive problem, okay, which means one event does not affect the other, okay? You can't get it both at the same time. Let's say that I was going to roll a dice twice, okay? And I want to know what the probability of getting a 2 and then rolling it again and getting a 4. The probability of getting a 2 is 1/6. The probability of getting a 4 is 1/6. These do not affect each other, and they are independent events, okay? They can't occur at the same time. I'm rolling the dice, I can't get both a 2 and a 4 at the same time. They are called mutually exclusive, and the probability of A or B, now this is an or thing, I don't care which one takes place, either one would be considered successful. So the probability of A or a B would be the probability of A plus the probability of B. It's not multiplied together, it's added, okay? Those cannot happen at the same time. So, let's talk back about our cards. Let me grab the cards back out. Okay, before, remember, we did a heart, or we were doing a king and a 10 or whatever we chose. Okay, now let's state it a little different. What's the probability of a king or a 10? I don't care which one I get. Okay, so I'm going to draw a card out. The probability of getting a king would be 1/13. Now let's say I put that back in. If I put that back in, then the probability of getting a 10 would be 1 out of 13 as well, or the probability of getting either a king or a 10 would be 2 out of 13, okay? Same deck of cards. Let's say we put all the cards together and I have 52 cards. And I go, what's the probability of getting hearts or diamonds? Okay, the probability of getting hearts would be 13 out of 52, because 13 of the cards in a set of cards are hearts. Or, remember the big key is whether it uses the word or and. The probability of getting a heart or a diamond, the probability of getting a diamond is also 13 out of 52. So I add those two together, I get 26 out of 52, which is equal to 1/2 or 50%. Okay. All right. Let's do one more. Okay. Alfred is going to Lakeshore Animal Shelter to pick out a new pet. Today the shelter has, all right, this is what he has. 8 dogs, 7 cats, and 5 rabbits. Okay, if Alfred randomly picks an animal to adopt, what is the probability that that animal would be a dog or a cat? Okay, probability of a dog or a cat. He's only choosing one animal, but I don't care which one it is. So there is a total of 20 animals here. The probability of a dog is 8 out of 20. The probability of a cat would be 7 out of 20. So that's going to give me a total here of 15 out of 20. I'm going to divide by 5, and that's give me 3/4 or 75%, because that's equal to decimal 75. Those are mutually exclusive. One is not dependent on the other, and it's or. I don't care which one it is. I want to know what's the probability of this or that happening, not this and that happening. All right. I'm going to go ahead and give you your homework on this, and hopefully, I mean, this is just a exposure to it, so do the best job you can. All right, page 773 through 774, 16 through 27, all, okay? And have a great summer.